So my name is Ladislav, and I'm the founder of Intel Maps. We are just 2 years startup. We just went through a European Space Agency incubator, and we got a few awards. And we do asset management maps plans. If you know what's asset management, just imagine you are a facility guy at this building, and you need to take care about it. Right, so Javier said it's the first skyscraper in Madrid, so probably there will be no data about this building. If you will get some data, so there will be maybe some papers, and if you got some CAD files, so you cannot open it. So what we do is this kind of data fusion for those buildings. Our typical customer, this is like a hospital. In Prague, there are about 500 rooms. And what about if they do some new air conditioning system, or they have a guy who is doing some revisions for fire extinguishers? So they need all the data about building. So it's how we started. It was just 2D application. But it's not enough. We decided, hey guys, we need to map this building. So we purchased some special laser scan. I will just show you how it looks like. Oops. I need to click on an icon. So this is in a gold mine, in a Czech. So you can just put it on your back, and you can go through some buildings or outside, inside, and about like half an hour, it will give you 3D position within a few centimeters. We were actually first guys in Central Europe who got such technology. And what's so unique? It got some GPS. You can work with few centimeters, 360 camera, laser scan. It got about 600,000 points per second, just 1 second, and you got almost 1 million points. And also we got some IMU and SLAM technology, so you can go through the building, and it will create for you this 3D spatial map. So it's really cool, because if you will do it just by land surveying, so like this building, it will be like CAD file with like 30 megabytes. So it's like super small. But with this equipment, you got about half of terabytes of data. So it's something to the roof. So it's a huge difference. And how to display those data? So you can buy special machine. You can buy software as AutoCAD or MicroStation. You have to do some special training for those people. But we said, no, we want to use it through web browser. And it's how we get to deck.gl. So what we do, we integrate many different data from different resources. So we use like 2D plans, some rasters from scanned plans. We use 360 images. We can integrate some outside data from the city about infrastructure, underground utilities, or we can integrate some scans from the building, and we want to put everything together. So there are some samples. So it can be like a building interior. This is from a point clouds. It can be also from outside. It's a georeferenced colored point cloud, plus some street view. Guys, hands up. With more CARTO. CARTO, 1, 2, 3, 4, great. Actually, we use CARTO open source software. It's really great. We started this a few years ago, but we use it because in a CARTO CSS styles, you can do those special symbols like for electricity, water valves. So it's quite cool things. Also, we can integrate some building information model. So you can click on a roof and get some information in different level of details. And what was the bug about actually? So it was integration between Street View and another data like laser silicon point clouds or building information models. Yeah, this is another example. It's a golf cars, which is done by LiDAR, and in the back you got orthophoto from a national surveying office. This is from drone, some high resolution picture, and this is from actually this 360 camera. It's like a textured meshes. Quite challenging project because do it from those cameras, so it's quite hard. There are just some external models which we are playing with. I can show you. And also what we do, we integrate some sensors from IoT, so you can really see it on a map. It's kind of flashing or moving, so it's like kind of virtual city. So it's really getting to be one-to-one, you know, digital twin. And what we have done in incubator of ESA, so it's a seamless outdoor-indoor navigation. So when you are outside, you got to the building and you can navigate with your cell phone, with your mobile phone application. So I can show you some real samples, so you can believe me that it's working. This is like kind of dashboard, so you can create some, choose your projects. This is just 2D plan, so you can click on some asset, and there are rooms with topology, and for example here you can edit some. It's a revision of the fire extinguisher. Those are cartography for outside made in CARTO. So you can see those special symbols for technical maps. And this is a project, it's a cemetery near Prague. So there's some church. What's still challenging in deck? So sometimes, you know, we are losing those layers, or sometimes, you know, those services are not working for whichever reason. But anyway, it's still quite good. We are talking about maybe millions of points. There are still huge data. So this is a university in Warsaw in Poland. So it's interior. So you can just see some sample from inside. There are some corridors. So you can kind of fly in. It's pretty cool. And this is the golf cars. It's just a project from yesterday. Some new data from drone. It's actually done by external company. And those are from a LiDAR, colored point clouds. This is what we have done for brewery. It's done by drone. So it's a 3D model with resolution about 1.5 centimeter. And the whole model, it's about 4 to 5 gigabytes of data. So it's quite huge. I can show the whole model. It's like this. Of course, we are, you know, dealing with different type of data because you got this model which is done within few centimeters, and around you would have orthophoto, for example, from national agency. So it doesn't fit together. You know, there can be difference like 1 meter. So sometimes this model is under orthophoto or is above, right? So there are still many challenges which we need to solve. Also zooming, you know, because just now we are 270 meters above sea level. Yeah, so sometimes you still think you are on a zero level. Those are external data we are just playing with. It's a Cairo with pyramids. It's done by photogrammetry from the airplane. So it's how we can integrate like external data together. And this is also external data. It's New York, And actually, those buildings are as objects, which is quite cool. They're open data, and we are talking about hundreds, thousands of buildings. So it's also like a big data sets. I can zoom out, and you can see the performance. It's really amazing. I'm just quite surprised. This is something more technical. So it's a house which is done in a building information model. So you can turn layers on and off. So you can kind of go inside, and just now we are working. So you can click on it and get information. And let's say it will be a surprise. Oh, and this is, I can turn off laser scan. And for example, this is the cellar under building. So it's like this is like a cut through a laser scan point cloud. So it's like for architect, if they are planning, there are supposed to be brewery, so they are planning new technologies, how to put it within this room. Let's see what's coming here. Oh, it will be like another point cloud. It's for factories. I can turn this one off and on. Yeah, so there are some floor plans. What kind of facilities they got, because some of those customers, they got no data. So it's like first view, wow, I can see some, how it look like, measure some distances, and get some first idea. So, oh, and this is indoor navigation, which is done in also in a deck. So it's quite interactive. I'm quite surprised. It's fast. You can play with that. It will be also on a front desk. When you go to hospital, you can choose your doctor. There will be like some list of doctors I want to navigate, and it will show you the way how to get there. Yeah, and you can see like here is like a flashing green line how to get to this doctor, and if you will get app, so it will show you where you are and how to get to this room. For this navigation, we use like beacons because it's quite less or no expensive solution. Each beacon costs like $10, so you can put it in a corridor. And this is an example of this bug, why we need first-person view and kind of street view and 360 images. This is this hospital in Prague, Poliklinika Prosek. So it's a 360 image, and you can see you can integrate it with another data like from a BIM. So you can building information. So you can click on a feature, and it will give you who made it, some contact. Just imagine there is some electricity plug, and you need to see electricity cables, wires, right? So it will show you it goes this direction to the roof when we join all the data together. So I will go back to my presentation. So what are our plans? If you will see each other on some Slack or GitHub, so just now you will understand why we need it, what we do with those data. So just now we are working on some measuring, distances, polygons. We are just talking about volumes for some of our customers. What's challenging to integrate 2D maps on a terrain. So like, for example, this is terrain, there is a cemetery, there are some parcel data. Yeah, so you can have all the 2D maps on a 3D map. So this is like this 2D map, for example, from CARTO. So how to join it together. I just talked to my guys, and I heard there's some good improvement in a deck right now. For us, it's quite important if we get this model, so we can do searching and querying through all the features. For example, find me all the windows which are on a north side of the building and are bigger than 2 meters, right? Square meters. So it will find you all the windows, and it will show it on a map, and you can just do export to Excel and send it as some demand for some reconstruction. We have also discussions about moving from CARTO to deck.gl. It looks like quite cool administration for cartography. We play with that. It's quite sexy, fast. So maybe makes sense. Also, we are playing with pottery. It's another way how to visualize point clouds. I was just discussing with Pat. I don't see him. He just gave me also some tools how you can export LAS or those point clouds to some special format. Or yeah, we are talking about 3D tiling, but there are still some limits because you have to use some commercial software like ArcGIS Pro from Esri or something, some different. It's still, if somebody asks me what I would use for data conversion, it's really tricky because for different type of data, we use different tilings. There are no simple answers. First, we have to do like cleaning, generalization, and after that, we do some 3D indexing, maybe some comprimation, decomprimation. So there are still a lot of challenges in this way. Last thing, what we are thinking about to do some online cross sections. For example, if you are an architect, or those days they are talking about energy savings, so you need to count some square meters for solar panels, for some extra, how to say, to make building less heating going outside. So you can do some, simple digitizing and do cross sections through point clouds. So there are some plans, and I would like to thank you guys, all of you. Especially we are taking care about deck.gl, loaders.gl. We are still on the way of testers. We are not such a big company like CARTO or Foursquare to have some developers, who will be doing just a deck. So I would like to thank you, Shiaze. Are you here? I can hear baby. Shiaze? No. Oh, okay. So you are on a screen. So I would like to thank you, in front of all of the guys. She helps us with this bug, and also I don't know if Victor is here, but he is also doing some fixing, and all of you who are doing this great support on this great product. So thank you.
Thank you. Is there any questions? Oh, yeah, Felix.
Hi, thanks for the presentation. I just wanted to ask, were you able to build this with the deck.gl layers as they are, or did you have to make your own custom layers?
Yeah, so we have to do like always 3D indexing. Yeah, sometimes we try to put data directly to deck.gl, like for example, point clouds. But we are talking about maybe 500,000, 1 million points. So it's really nothing. It's just 1 second from this laser scan, and we are talking about billions of points. Yeah. So like I said, you have to try to use different formats and integrate it. Yeah. Good question.